So these are my project drawdown solutions. So the first is a high-speed railway. High-speed rails are a railway system that are made for speeds around 150 miles per hour. It is electricity-based and is the fastest mode of transportation from city to city travel. It can reduce 1.6 to 3.62 gigatons of carbon dioxide emissions by 2050. To integrate in the future, the largest need is large-scale construction of HSR tracks globally to establish a cohesive network, and we need to calculate travel densities to predict passengers per kilometer, so basically where to build them based on how dense parts of the US are. So some of the drawbacks are it is very expensive and needs a consistent level of ridership to warrant expenses. This is why population density is so crucial and as to why it's so successful in China. Also, a full aircraft emits less than a near empty train, even though per passenger emissions is lower individually on a train. So we need to incentivize people to use these, otherwise the costs will outweigh the benefits. So my second solution is ocean power. Ocean power is the use of wave energy converters and tidal converters, opposed to coal and natural gas plants. Wave energy converters turn kinetic motion of waves into electricity, and tidal stream energy uses turbines to convert tidal currents into electricity. This is expected to reduce greenhouse gas emissions by 1.27 to 0.80 gigatons by 2050. So future integration, overall installation is fairly expensive per kilowatt at around $7,200. Net first cost at around 200 billion, with operational costs sitting around 1 trillion. So it's fairly expensive. And it's also very young in its development and only accounts for a small percentage of global energy production. So still much is needed and needs a large push from government to implement wave stations. So some of the drawbacks include that marine environments are not the most forgiving, especially in the early stages of installation. And tides and currents are predictable. The development of these systems is not and is still young and new. So a lot of troubleshooting to be had. And it only can be deployed commercially in specific sets of conditions. There are a lot of technical, financial, and political obstacles regarding government incentive to push these projects. So now I'll discuss the trade-offs pertaining to both solutions. So for the high-speed railway, as aforementioned, it is extremely expensive, but if employed by populations on a large scale, it could prove to be cost effective. So implementation is really expensive, and operational costs are actually more than the air industry. So the largest trade-off here would be the replacement of the air industry, but people have to use it at a very high rate for the benefits to outweigh the costs. And the next largest trade-off is the land needed to build these and the various ecosystems it will likely run through and impact. So to build these, likely many ecosystems will be destroyed. So for the ocean power trade-offs, it is more expensive, but better alternative to replace natural gas and coal burning electricity generation. So there's a trade-off there. And then the other big trade-off that I noticed was installation and overall production will likely impact marine ecosystems to a great extent as a major trade-off. So to implement these stations, likely a large amount of ecosystems and species will be heavily impacted by waste or the installation of turbines